Example 15.3, it's about finding the performance parameters of a single-phase full converter drive. So we have a full converter drive for the armature and a full converter drive for the field. And here we are given that input voltage is one phase 440 volt RMS 60 Hertz. The armature resistance is 0.25, RF is 175 ohm, kV is 1.4, and load current IA equal 45 ampere. And the field current is set to the maximum possible value, so alpha F equals to 0. And we are given that alpha A equals to 60 degrees. We need to find the developed torque by the motor, the speed omega, and the input power factor of the drive. Here we need to find the input power factor of all the drive, not only the armature as we did in the problem 15.2. So we will start with part A. Part A, I need to find the developed torque. It's kV times IF times IA. I already know that IA is 45 amperes and kV equals 1.4. I need to find IF. Here we have a full converter. IF equals VF over RF, and VF equals to 2 Vm over pi cosine alpha F, because it's a full converter. And since VF is set to maximum possible value, so alpha F equals to 0. And thus we can find that VF equals to 396.14 volt, and then IF equals VF over RF equals 2.264 amperes. Once we have found the value of IF, we can put it in this equation and find that developed torque equals to 142.63 Newton meter. And this is a high value of torque. Now move to part B. I need to find the speed. So the formula that has the speed that is EG equals kV times IF times omega. I know IF and I know kV, so I need to find EG before finding the speed. EG equals VA minus RAIA from KVL. VA is the armature voltage, so the armature voltage here. And we know it's a full converter, so V equals 2 Vm over pi cosine alpha A, and alpha A is given equals to 60 degree or pi over 3 radian. So I have VA, IA is given at 45 amperes, and RA 0.25 ohm, and I find that EG equals 186.82 volts. And now I can calculate the speed in radian per second. It's EG over kV times IF, and that gives 58.94 radian per second equals 562.8 RPM. And this is a low speed for motors. Now we move to part C. We have the torque and we have the speed, and we need to find the power factor of the drive. I redraw the whole drive, so I have inside my drive two converters. The first converter is for the armature, and the second one is for the field. And I have the armature current from the armature converter and the field current from the field converter, and both are full converters, single phase full converters. And I need to find the power factor for the whole drive. So the power factor is the real input power of the drive divided by the apparent power of the drive, VA, which is Vs times Is. So the input power of the drive, since our converters are efficient at 100%, then the AC power of the armature is equals to the DC power and the output of the converter. So PA equals VA times IA, PN equals PA plus PF, power of the armature converter plus power of the field converter. PA equals VA times IA plus PF equals VF times IF, and we have calculated all the values of those the values of VA, VF, IF in the previous parts, and I found that the input power, the input real power is 9810 watt. Now I have Pn, Vs is 440 volts given, so I need to find Is. The Is is the RMS value of the source current. The source current is divided into two currents. It's the supply for the armature converter and the supply for the field converter. Then the RMS value of Is equals square root of ISA square plus ISF square, where ISA and ISF are the RMS values of the source armature current and source field current. Here, just a small remark. In the example 15.2, we had a semi-converter. For the semi-converter, ISA equals IA times square root 1 minus alpha over pi. Since in a semi-converter between 0 and alpha, none of the two thyristors are conducting, so we have zero current, and then we have current equals to IA between alpha and pi. However, in a full converters, between 0 and alpha, we have a negative current. We have a current at minus IA, then a current at plus IA, minus IA. We do not have any current equal to 0. So when I need to find the RMS value of IS, it will be equals to IA. Since when we do an RMS value, we do everything to the power 2, and then we calculate the square root of this value. So I got as ISA equals to IA. So this is just to note, between a full converter and semi-converter, we do not have the same value of IS. Here we have two full converters for the armature and for the field. So IS will be IA squared plus IF squared, which gives 45.06 amperes. And now we find the power factor of the whole drive is Pn divided by the voltage times the current of the source, and we find that power factor is equal 0.496 495 lagging, and this is a very low value of a power factor.